Hello guys, welcome back to my channel. My name is Gede Pasek Sunanjaya. My student identification number is 230553107. Then my lecturer is Prof. Dr. Tjokorda Gde Tirta Nindhia, ST MT M Eng from subject Metalurgy TM2301. And today I want to show you about my presentation about modern alloy production. So this is my profile. For the base reference for my presentation is from book Metallurgy for the Non-Metallurgists, edited by Arthur C. Reardon. Modern alloy production. This is my sort of the content. So, effect of alloying on solidification. The solidification of alloy is a complex process. It is most easily understood by examining how the solidification characteristics of alloy differ from those of pure metals. This is topic discussed to extend in chapter 2 in briefly expand in this section. Solidification structure. The solid-liquid interface during solidification normally exhibits one of three types of crystal growth in the liquid: planar, cellular, dendritic growth, as shown in picture 5.74. The type of growth is controlled by a manner in which heat is removed from the system when the liquid ahead of the solid-liquid interface X0 has a positive temperature gradient. Heat is removed from the liquid by conduction through the growing solid. Because the temperature gradient is linear and uniformly perpendicular to interface, a smooth interface is maintained and the growth is planar into the liquid. Picture 5.48. When there is a temperature inversion and the temperature decreases ahead of the solid-liquid interface, then either cellular or dendritic growth will occur. Figure 5.4 B and C. The difference between the two is a matter of degree. Small undercurling tend to produce cellular growth, while large undercurling tend to produce dendritic growth. Cellular growth as illustrated in picture 5.5 occur when the advancing planar solid-liquid interface becomes unstable and a small spike appears on the interface that then grows into a cellular type structure. The planar surface becomes unstable because any part of the interface that grows ahead of the remainder enters a region into the liquid that is a lower temperature. The initial spikes that from remain is isolated at first because as they grow by solidification, they release their latent heat of fusion into the adjacent liquid, causing a localized increase in temperature. Consequently, parallel spike of almost equal spacing advance into the liquid. Melting furnace. A wide variety of furnace technologies are available for melting metals. In steel making, for example, pig iron is produced in a blast furnace from iron ore, limestone, and coke. Picture 5.13. Because it contains excessively high level of silicon, manganese, carbon, and other elements. These are liquid iron together with scrap and fluxing agent. It then introduced into either a basic oxygen furnace or an electric arc furnace for further refining with oxygen. The objective is to reduce silicon, manganese, and carbon to acceptably lower level in the resulting state. Vacuum induction melting or induction furnace. Melting under vacuum method in induction heated crucible is a tried to tested process in the production of liquid metal. It has its origins in the middle of 19th century, but the actual technical breakthroughs occurred in the second half of the 20th century. Commercial vacuum induction melting, or VIM, was developed in the early 1950s, having been simulated by the need to produce superalloy containing the reactive element within an evacuated atmosphere. These advantages have had a decisive influence on the rapid increase of the metal in production by VIM. Flexibility due to small batch size, fast change of program for different types of steel and alloys, easy operation, low losses of alloying elements by oxidation, achievement of very close compositional tolerance, precise temperature control, low level of every round metal, pollution from dust output, removal of undesired trace element with high vapor pressures, removal of dissolved gases, for example, hydrogen and nitrogen. Foundry casting. Foundry use various methods to cast part with complex shapes and interior surface. Molds are made in a variety of ways so that the molten metal poured into the mold cavity result in a part with the shape and dimension of the finished form. Shape casting method can be divided into three broad categories: casting with expandable mold, casting with reusable, casting with reusable permanent mold with a high pressure metal injection of the metal into the mold. Non-ferrous casting alloy. Acid cast. In terms of tonnage, cast iron is the most common boundary alloy, constituting approximately 3/4 of the worldwide production of casting. And there's three types of casting. First, copper casting alloys, magnesium casting alloy, and zinc casting alloy. Powder metallurgy. One of the more recent metallurgical development in manufacture of modern alloys. The general types of atomization process encompass a number of industrial and research methods. Industrial method includes fluid atomization, where liquid metal is broken up into droplets by impingement of high pressure jets of gas, water, or oil. Centrifugal atomization, where a liquid stream is dispersed into droplets by the centrifugal force of a rotating disc, cup, or electroda. Vacuum or dissolved gas atomization, where a molten metal is supersaturated with a gas that causes atomization of metal in a vacuum. Ultra atomization, where a liquid metal film is agitated by ultrasonic vibration. And also there's a water atomization and gas atomization. So guys, that's all of my video. Thank you for watching, and sorry for my misunderstanding words. See you on the next video. Bye.